Let's go for it. So, hi everybody, thanks for joining. I'm Finley Asher. I'm an aerospace engineer and I'm part of Safe Landing. We're a global community of aviation workers, students, and enthusiasts that care about our industry and the future of our planet. So, we're really keen to understand what the future of the aviation industry could look like, and we're really keen to platform some of the companies and innovators that are really pushing the boundaries in terms of what's possible when it comes to sustainable flight. So I'm really excited today to have David Smith here with us of Robinson Helicopter Company. How you doing, David? Do you want to just give a brief introduction to yourself?
Sure. 21, 22 years in the business here, and most of my time has been in the helicopter industry. Did some work in flight simulation and training, had a 5-year journey on that. But most of my time has been working on both civil and defense applications of helicopters. So really love that. Didn't, set out to do that. I always loved space and really mostly not around aviation in my early life, but loved fighter jets and things like that. Would have done some of that if I had the ability. I'm medically disqualified from being a pilot, but that led me down the path of being an engineer. And so I have my undergrad at MIT and my master's from University of Texas in Austin for business administration for that piece. But my undergrad was in aero engineering, so rocket science at MIT. But it was a tough ride, and so I'm not the greatest engineer, but I have led some great engineering organizations, and now I lead Robinson Helicopter Company for the last 3 years, where we've brought in both things in the alternate propulsion category we can talk about today, but also we got into the unmanned space. I have a division called Robinson Unmanned that makes small, extremely power and energy efficient little helicopters for all sorts of military and commercial applications. But super excited about all of those things that are in the future of aviation and mobility. So, yeah.
Nice. Yeah. And so just a little bit more about Robinson Helicopter Company then. Like what is the mission of your company
Yeah.
and what are your plans?
So 53 years ago, our founder Frank Robinson was one of the I think best examples of what a founder should do in a startup like aviation, a product startup. Built the business right from the beginning. His vision was a personal helicopter, one that he could fly and could have, provide himself point to point transportation. And he did exactly that. He used his career founding the company in his early 40s, so fairly late by the standards of most startups these days, but had done it in a way that didn't take on excessive debt, didn't have venture capitals backing him, did it off his wealth and a couple of peers that he used as partners in the process, but did the hard stuff first, worked the product, kept the team small, lived frugally. His daughter made sandwiches for all the engineers and they cooked things. They actually bonded the rotor blades in his home oven for the first units. Things like that that are, if you think about the founder of today, they're not like that. They get a cash out way up front. They're making 9 figures, 8 figures, 7 figures early before they've really reached pay dirt. And so I think it's a whole different upbringing that led to Robinson. Now, today, on the foundation that Frank laid, we are the most vertically integrated, the broadest connection with MRO, so maintenance, repair, and overhaul in aviation. We have the highest control over that. We have the largest civilian helicopter fleet. We routinely are the highest production on an annual basis. We still have the highest record of the most helicopters produced in a year. 896 were built in 2008. Things changed after the financial crisis, but ultimately we will get back to over 1,000 ships a year again. And helicopters have amazing advantages, and they do things that save lives, defend freedom, produce food. If you eat cherries, drink wine, love grapes, eat tuna, eat steak, most of those depend very much on our products and exclusively. The alternatives were built in the 50s and 60s and have long since been unable to be maintained. So we are the dominant force in agriculture, fishing, and then on top of that, pilot training to build air medical pilots and oil and gas pilots and the like. So a lot of really interesting things our business is doing and we're up to, but that's a good summary.
Thanks very much. Yeah, so you're the largest civilian helicopter company in the world, right? And actually, because my background, I was at Rolls-Royce for 8 years, and I remember I worked on very big jet engines. And I remember being quite surprised when I looked up what the most mass-produced engine was, and it was actually the relatively small one that goes in
Yep.
that goes in one of your helicopters.
Yep.
Um, and yeah, I think just looking at the design as well, like it also looks like almost like the art of simplicity is being gone for. We think of helicopters
Yeah.
as
I mean,
quite
I
complex
can't.
things, and
That's right. I can't stress enough that one of the reasons why aviation has become as accessible as it is on an adjusted basis, the ability to get from I'm flying to Australia on Sunday night, and to get from U.S. to Australia without boats and weeks of time lost, to do that safely at mass scale is the product of, among other things, simplicity. So we feel very strongly that aviation has to have a constant pressure because engineers make things complex. Humans naturally make things complex too. We're little entropy machines creating chaos as we go. And to keep things on a trajectory where safety improves, economics improve, you have to keep simplicity as a prime directive. So our products are built that way. We don't put non-essential functions in the aircraft by a rule, and that helps us keep the efficiency. We are the only manufacturer of helicopters that builds a product that lifts more than it weighs. And that's, obviously a pretty important part of anything you're going to be moving cargo or people or, you know, whatever.
absolutely. So really excited to hear about so I know about the electric R66 helicopter demonstrator that you're working on
Yep.
with Magnix providing the electric motors, but you're also saying, there's some hybrid electric and hydrogen power and studies being done. Can you tell us
Yep.
more about like that project and some of the other
Sure. So,
propulsion
so I'll give
technology?
you,
Yeah.
yeah, two different flavors of it. First, we're on our fourth generation of full electric helicopters. All of this, the first three generations were done really at the direction and the leadership of United Therapeutics, their subsidiary United Bioelectronics. They're a phenomenal group of engineers and committed folks for a mission. Their mission is to take organs that are developed and harvested as part of United Therapeutics' primary business, which is medicines and organ replacement in the world. And they're really on an amazing path for that. They've got multiple technologies that both ensure more viability of existing organs that are harvested, but maybe not meeting the specifications of last generation's capabilities. So they rehabilitate those organs and then use them in successful transplants. And then others that are grown and harvested within pigs that can then be used in human transplants at great success. So I think those are amazing technologies that are going to be massive life-saving engines for the future, but they need distribution, and distribution for something that has a very tight shelf life. You need to get it into a viable patient very soon. Vertical lift is the best solution for that. Obviously, sometimes longer distances, fixed wing might work. But so they're doing all of that, and they've been funding it for more than a decade now to try to get to a zero emissions VTOL and ultimately fixed wing as well capability. And they've worked with companies like Beta Technologies, with EHang in its early years, and with Robinson and Tier 1 Engineering that did the early first three generations of our electric R44. On the backs of that R44 project, at the end of the third phase, they determined they needed longer range than what electric was going to reasonably achieve. And that is, I think, a lesson for all. You need a couple hundred nautical miles or 100 nautical miles. You're not going to get it with pure electric under today's chemistry. And that is a reality that the real professionals know. Many people in the investment community do not. So be careful what you invest in. That's one of my lessons learned here. But ultimately, their solution has migrated towards a hydrogen fuel cell based system that really works well. We've been doing a lot of up and away flying last few months. We've flown it for about a year now. It's a great aircraft. It's lower noise. It is zero emissions, producing water. That's a really great outcome. The current generation uses gaseous hydrogen, which is not great density wise. Liquid hydrogen is our next iteration. That'll be done on an R66. Ideally, it'll fly sometime late this year, early next, most likely next at this point. But we'll see how the team's executing. They're flying the 44 and learning a lot, so they're not under as much pressure to get the 66 version in the air, but they will soon. So that's the hydrogen fuel cell. And I'll just, for folks while I'm talking, I'll share the video playing in the background so folks can kind of see what I'm talking about. This is a video that I've shared on it. It's a talk I made to a group out in Up Summit, which is a great future tech um, summit that we do annually, and it's a really great gathering of minds on sustainable aviation and the like. But this is a video of our hover testing of the hydrogen fuel cell R44. 66 gives you more payload, and it is likely to be a better power plant matching. One of the big things that people have to know is, most fixed wing aircraft, their props turn at a very relatively slow speed, 2,600 RPM. That means you got a really big motor to turn slow enough and carry the torque, the extra torque that brings. For our application on a 66, we go up to 6,000, 2.5 times the torque. That gives you, or 2.5 times the speed, which reduces the torque quite a bit. And so ultimately, we like the idea of a 6,000 RPM electric motor. It's super packed, very power dense, can actually give redundancy in the primary drivetrain that currently engines don't have. So we love that. It's a really nice opportunity. And so when we were doing the hydrogen fuel cell work with United Therapeutics over the last couple of years, we also decided we would go and evolve that fourth generation. That's an R66 Focus variant, the very first ER66. All the others have been 44s. And that will give us the latest batteries, the latest motor technology with this denser motor, with the redundancy designed in from the beginning. And we do think that the regulatory environment is starting to converge on certifying motors. We have pretty good confidence on the batteries as well. And ultimately, the time is upon us. But I'll just say that the performance is still going to be very limited. We don't know if it's commercially viable in its current, sort of equation of value, range, endurance, payload. But helicopters are going to win on VTOL. All the other guys have an architecture that's going to destroy batteries. It is actively destroying batteries every few hundred cycles. So we believe we'll have the superior architecture versus what has been, I think, marketed very well for the multi-rotor designs. So
Yeah,
yeah,
well, we'll get into a little bit of the comparison there between the electric VTOL and helicopters in a second, but just
yeah.
just kind of at a higher level, could you talk us just through, in your opinion, what some of the opportunities and challenges are with these propulsion systems? You mentioned a few of them
Sure.
already, like the energy density of the batteries, the volume of the hydrogen, and but yeah, just some more detail there for what you're up against.
So back to what I think drives our business is sustainable entrepreneurship. This idea that we basically provide product that people can build a business around, whether it's tourism or agriculture, utility, charter. These are all missions that people do oftentimes as a part of their whole business, and they do 3 or 4 of these, or 5 or 6 of these things. Sometimes flight training interwoven to all of that. So you need a multi-tool to be effective in what is this sort of entrepreneurial core of general aviation. There are products out there that can be entirely commercial. We'll talk about net jets buying Latitudes and big Citation jets and things like that. There are plenty of products that work that way, but those are ultimately a very different market and a different set of capability. So we're not in that space, and none of these products have been considered to be in that space either, the competitors. So to us, you need something that is multi-tool with lots of capabilities and the ability to operate somewhat independently. So you're not constrained to heavy infrastructure exposure. You're not constrained to sort of the impacts of isolated access for power and such. So we're trying to make things from the very beginning very accessible as a core attribute. And so we're trying to adopt things that are commercial standards for battery charging apparatus. We're also trying to make sure that the logistics chain of moving batteries in and out of the aircraft isn't something where you're like I had this example recently. I had one of the little charging packs that had a lithium cell, a pouch that was defective and that had a recall. Well, what do you do with an exploded or expanded lithium pouch right now? The answer is not clear. Every fire agency here in the US has a different answer, and their answer generally is, we don't touch that. Unless it's actively burning, we don't know what to do with it. And if it's actively burning, they don't know what to do with it either, by the way. But if it's not actively burning, you're trying to deal with who in waste management is going to pick it up, or what city entity is going to take it and destroy it and dispose of it safely. There's not great answers for that on the lithium battery problem. And that's commercial products, not even aviation, where there's higher density and a bigger challenge. So we want to make sure those things are addressed and are part of the thinking before we hoist this onto a customer and say, sorry, it's your problem to deal with. So when you think about what you don't hear from the other guys, it's that stuff. And I think we know it is the first order driver of success. All the other stuff melts away. I mean, like they'll advertise, I've got this route booked up with an airline, or I've got these heliports that I've got some familiarity with. All that is silliness. What stands up to the cold gravity of the world is dollars and cents, practical things like moving material around through the enterprise and the cross borders and all that. If they're all coming from California, how do you manage shipment of all these hazardous goods to places that really have restrictions on them, like Australia or New Zealand, Europe for that matter? I mean, so these are challenging things that we've already addressed before. We do lithium cells, lithium batteries for our primary ship batteries as an option. So we've been handling lithium shipments for a really long time, but there's a different cut as you get into denser chemistries and more complex chemistries and all that. So anyway, so I think that's one big set of problems. It's logistics and scale and commerciality of it. But the other side of it is I also think that when you look at the first order driver of safety in the industry, there are really two types of things in commercial of how pilots fly aircraft. There's side sticks in Airbus, and there's yokes in Boeing. If you added 7 other flavors of how aircraft were flown in commercial, you'd end up with a significant safety exposure of habit transfer and standardization of crews and how they move between aircraft or how they move up in the ranks and they progress. Those habit transfer topics matter a lot, and they're a driver, one of the biggest drivers of the routine aviation, commercial aviation success, and why I think we offer a huge advantage where customers will fly a mixed fleet for maybe a generation, maybe 2 generations, 40 years. We'll be flying a mixed generation of jet fuel powered product and electric powered product, and maybe hydrogen in there as well. For us, all of those fly the same way. The aircraft performs the same, the rotor does the same things, you move the stick this way, it responds the same way. That has a huge intrinsic value that others just have not even realized. They probably realize they're weak on that, they're just not talking about it. But I think standardization of cockpit and human factors, and also downstream, maintenance, shipping logistics, repair and overhaul, all those things matter a lot. They drive things like what happens when you have a bad day and someone drives a forklift into your aircraft, which happens. How do you repair that? For them, every one is a one-off snowflake of carbon fiber repair. For us, we have a standard FAA document that's been built since the 60s or 50s and tells you how to repair sheet metal structure in the field. And so we have a lot of things like that that are advantages that come with 53 years of heritage built off of a 90-year industry versus startup new stuff.
Thanks. So just in terms of like the kind of capability benefits of this stuff, you mentioned so cost is a big thing, but just thinking about like noise is important. You mentioned lower noise. So would you expect that each of those power systems, the noise is lower, and is that primarily coming from you're removing a jet engine or a internal combustion engine and replacing it with a fuel cell or electric motor that's relatively quiet? Or is it like also the rotor itself because you can
So
control
they're independent challenges. And so, for example, if you have ever been on a farm, tractors are loud. Our piston engine aircraft have heritage back to tractor engines, and they are loud. And they're particularly loud on the ramp and in the area right around takeoff and landing. But you can pick them out of the sky too. And turbine engines are even louder at a different frequency, but they're very, very loud. And so what people don't realize, that's the first order driver of why people don't like commercial traffic in an airport near a neighborhood is actually the turbine engines. So one of the big levers that moves the needle on noise is replacing the power plant. And we are excited about that. And that's one of the reasons why we like the idea that down the road, things like routine traffic, which would be things like training, where you fly out of an airport, you do pattern work around the sort of airport perimeter, and then you fly in a neighborhood just adjacent to it. That can be very disruptive to neighborhoods. And we see that with fixed wing that are operating on our airport here in Torrance, California. And so we want to mitigate that and help improve aviation noise around the repetitive sort of particularly nuisance noise that can be improved by this. So that's one of the exciting opportunities for these electric 66 is that we potentially can get to a point where that is a product that meets an hour plus flight time, hour plus reserve. That would mean a meaningful training sortie that you could actually do much of what we do today, burn in piston engine time as it stands. The challenge, though, is to get to that, it's a much more expensive product. So just to give relative scale, for a engine of equivalent power to the piston, it is on the order of 2.5 times the cost. That's just the motor. When you include the fuel cell, battery, whatever the source energy is, that likely triples the cost of the system. Now, I think there's a way to eventually get simpler batteries. One of the problems is the complexity of batteries. They are the most complex part in any aviation product I've encountered. And I did fly-by-wire systems. The batteries are incredibly complex systems with the management systems and all the sensors. But down the road, I hope we can get to a simpler battery that is more like what you see in cars or what you see in consumer products. That would be really helpful to the industry. So ultimately, that can get the cost down there. But cost is way out of bed from what today people pay for training, for example. So that's something we got to go and attack.
And the hydrogen cost as well as the actual fuel, right? And you're
That's right.
saying about like versatility and things and ability to land somewhere and have the fuel. So I would imagine that's quite a bit of a challenge, just
It is.
considering.
I don't see so far these solutions tend to lean towards fixed radius missions. So some examples that are really exciting, though, are there's a lot of ships that are on boats that are used in the tuna industry. There's a lot of ships that are on boats that are used in private transport or commercial logistics, moving captains on and off of boats in harbor and things like that. Those keep the economy going. I mean, it's shipping of everything, oils and food products and all that. Then there's mining. Mineral extraction is a very important part of the world today, and especially with things like what we use for computers and magnets and batteries and all the like. We need good mining logistics, and they would like the mining companies have approached us as I'd like to have a helicopter that is basically tethered to our facility that can go basically back and forth to the main metropolitan area and move material or medical relief if there's an injury on the site, or move drill bits, core samples, whatever. That's all stuff that's pretty exciting, but I don't think you're going to do like lots of cross-country flying between infrastructure points. You're just not there yet. We're like where Tesla was in probably 2010 or 15 or whatever.
Got you. So
You know,
there'll be a central hub where there would be hydrogen, but then you go out and you come
that's right.
back. Got you.
That's right.
Okay. So
My
yeah, I'm
hope
keen.
for hydrogen, though, just as a side point, is
Yeah.
my hope for hydrogen is that the future we see in front of us is one of abundant energy, and I do think that is probable in yours and my lifetime. That the data center investments and the ability to localize production of energy. That when you look at AI data centers, they're probably going to end up with some periodic demand. So while people are awake in the time zone, huge demand, lots of consumption, lots of computation. At night, it's more learning and slow learning and learning and learning, learning, but it's lower base load. During that gap period where you have huge production capability but not a lot of demand, we will produce hydrogen. And I think that's part of the goal of fitting inside of an infrastructure wave that we have never seen before in human history. That's going to be this massive investment in power for AI enablement and future technologies that we haven't even considered yet. So I think abundance is on the way.
Okay. Well, I hope so too. Yeah. And so just yeah, just really keen to that just get into the specifics of this eVTOL versus helicopter discussion with you.
Yeah.
So I've seen, I've seen you comment a lot about on this topic. Obviously, like in the world of electric aviation, the area that has got more funding than anywhere else, and actually like more funding than sustainable aviation fuel, is this electric vertical takeoff and landing concept. Tends to be multitude of rotors, often transition modes from vertical takeoff into forward flight. Um, Complex control systems. I mean, they look really cool, but also really complicated. And I'm really interested just in your take there, and how you talk through someone like new to the topic,
Yeah.
pros and cons, and why you think like electric helicopters or whatever will win out, but also like maybe if there is going to be some balance between the two and potentially for some
Sure.
applications.
So give me two kind of things to think about. First, in my people will look at me and think, "Oh, you're a helicopter guy." Actually, when I took this job, I had an equal spent a lot of time traveling to decide between leading a public eVTOL company. I had the offer to go and take on their CEO position. I declined in the end after spending lots of time with their engineers. And if you're a product company and the product answers don't make sense, you're not much of a company. And I think that was ultimately my judgment coming out of it. So I come with a great deal of depth, much more than people realize about the eVTOL distributed electric versions, and what that really means. And I'll give you kind of two guiding principles. One, if you take off and the first thing you do is you turn off massive cost driving systems and you stow them, you're bad. You're starting off with a very, very significant headwind. Um, Long ago, you think about aircraft carrier launches of fighters and bombers. The idea was, would you design a different aircraft to handle the short takeoff requirements? They looked at all sorts of things from rockets and rocket launched versions. Ultimately, they did something very smart, which were steam driven catapults. And that actually helped a lot with what they needed. They also did in air refueling to help increase the range. Those are elegant solutions to an energy problem. What is not elegant is if you try to carry the entire band on your back, like the Clampets or something, and that's what you got with the eVTOLs. That's a U.S. TV reference, but it is an insane engineering environment where those rewarded by most funding make the most insane contraptions. The Chinese one that is a crime against humanity to me, of how many props can you put on a thing and turn them off and then turn them back on and turn them off. That's an insane design that should never really get any airtime. And it's travesty that Aviation Week put it on the cover, for example. That tells you where our industry has gone. Very, very disappointed in the industry for not calling that what it is, which is shamelessly bad engineering at its core principle. And the argument is, never in humanity's history have we gone from fewer reliable things to greater numbers of unreliable things. That's a terrible approach. It doesn't make good engineering sense. And then of course you turn them off, turn them on, turn them off, turn them on. So that's just lugging stuff around you don't need. So ultimately not a great sustainable, if you're thinking about sustainable stories, this is a very bad sustainable story. I look at it as the Hummer EV was a hilarious experiment on what is sustainable and what is electric. It requires so much energy to drive this humongous heavy SUV that it ultimately isn't sustainable or green or the best use of energy at all. You'd be better putting gas in it in a different vehicle. And I think the same way about all these EVs that have like 6 motors or 4 motors or 5 motors. You need as few motors as possible. If you want a sustainable solution, you need as few motors as possible. And that's the solution that's best for resource allocations of rare earth elements and manufacturing know-how and all that. But it's also just that's the principles we should be living towards, is simple as required and no simpler. And that's the way to think about things. And these are the opposite of that. Now, back to the other topic, which is the physics of it. If you have to VTOL, you want a large wing. If you have to fly long endurance, you want a large wing. So these are neither of those things. They've got short, stubby, stiff wings because you got physics, aeroelastics that have to make these things ultra stiff and to manage dynamic phenomenon that have broken tilt rotor aircraft, by the way. And so you have these really short, stubby wings that aren't great aerodynamic surfaces because they're covered in scabbed on props and booms and the like. And they're blocked by all these sort of appendages that you don't need for half the flight or 80% of the flight. So it's a very strange camel monstrosity that just doesn't make a lot of sense. And people who are in this industry that are getting paid by those companies, they tell me that I'm right. And I know I'm right because physics is simple. And we get refugees here from the industry that are former employees of Archer, Joby, Supernal, Vertical, Overair, et cetera. And so we have a lot of those folks here. And this is the truth. But everyone has a price. Those people they're paid a lot more in those industries because the money is great. And so they keep their mouths shut and they don't talk about it until ultimately we Theranos our way into an implosion. So I think it is going to end badly because the physics aren't on their side, the scalability and economics aren't on their side. Even the core principle and alignment with sustainability doesn't make sense. So that's where we are. I would say I love the fact that more people are excited about vertical lift. And I think there are betters amongst the bad ones. Joby's is probably the most evolved. And I like the fact that their systems use everything all the time. That's a great first principles argument. They have some great folks in their team that I've worked with in the past that are excellent and very sharp. But a good example of how they're not sustainable is they've got over 2,000 employees already in like a bunch of countries. No GA company can sustain that type of overhead at all, period. Like you just can't do it. And they're not circling the math that makes that possible either. So I think there's a whole other argument from my business hat that says, what are we doing, guys? Just what are we doing? So
Just
that's a summary.
yeah, thank you. Dan, I know you've got more to say on that, so thanks for keeping it short. I'm really keen to stop and just make sure we've got a bit of time for questions.
Yeah.
I was just on that. I was kind of interested. Do you think that it has resulted in an acceleration of like, because at one point I was a bit of an advocate for eVTOL, because I thought it's maybe like the first thing. Like I'm really keen for electric flight of all sorts to be
Yeah.
accelerated,
Yeah.
and it seemed like there was money being thrown at it. So it was like, great, we'll get some electric motors, and control systems and batteries flying around, and you'll have to go through the certification challenges for those things. And at least it will like accelerate the technology development and knowledge there that could then maybe be transferred to something that's more simplistic, aerodynamic,
Yeah.
longer
I mean, I
range.
wish I wish the fractions worked well that way, but like if you take a dollar that's going into this industry and you boil it down to what goes to those things that push us forward, it's probably less than 5%. Much of it's hype, a lot of it's lobbying, a lot of it's regulatory capture, bad, 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 a lot of bad things. Then down at the very end, there's base improvements in power density, energy, and chemistry of batteries for high power discharge requirements, something not required for cars, so different whole need. All those things, yes, there's some of that, but I don't think the ends justify the means. And I think that ultimately what will result from this is aviation will be an uninvestable category in hedge funds, pension funds, venture capital for 10 years, 20 years. I don't know. It's a long time potentially where these people will be wary to invest. So I think that's worse than the net benefit. So I'm a big believer that we need to hasten the demise of all this and get to the end game that physics and economics demand. And ultimately, this is just, it's also sad because there's people who won't live to see the benefit. So anyone who's currently an investor and is in a pension fund or in a, they're not intentionally spending their money this way, but their pension managers are. And it's tragic because they won't see the benefit of it. And all they'll get is the big dip down when these things implode inevitably. So I would rather, as an example, take 1/10 of all the dollars spent. Maybe it's $1.5 billion. And what I could do with $1.5 billion in our business is I could build a portfolio of all electric aircraft. We spend very frugally. We have a hugely beneficial fractions here, business fractions of overhead versus touch. So when I spend a dollar, there's no one spending it better than the way Robinson does. And we can't get money for stuff like this. There's no grant money for us, that we don't have the lobbying arms that these guys have. And so it's hard to justify ends and means,
Do you think, just in terms of that, like getting that message out there, do you think it's most important to convince like the investment community, or and what role do you like, or else do you think that like government has a role there in terms of like some of the funding schemes that go forward in the US, for
Yeah,
example,
it's
and what they
it's got to be
select?
all. It's got
Yeah.
to be all because I have similar risk about suppliers and how they allocate their time in R&D. The number of times people are like trying to invent something specific for an eVTOL application that's not going to work. It's like, a dodo bird investment, it doesn't make sense. There's that concept is hurting our suppliers that we share. There's people in the chains we share. And then I think similarly, regulatory, those folks matter in the government space. They're spending a lot of time writing rules for this stuff that will be, dusty and ancient and never used. And then the same thing for elected officials. A lot of people who are mortgaging their campaigns in their regions. So you think about the state of Ohio, the state of Georgia, that are committed now to these big monuments that are going to end up like mausoleums, just, holding a bunch of things that never were. And I know that's coming, and I feel for the communities that are going to be hit by that. So yeah, I don't feel like there's no shortage of things that need to be influenced. Investors are one of the challenges, and I don't worry too much about venture. They'll that's part of their lifestyle. The pension funds I care a lot about. Firefighters, teachers, police officers should have no connection to this. What is likely to be a complete debacle for the next 10 years.
Okay. Yeah. Thank you. Okay. So rather than ask you some more questions myself,
Yeah.
I'll stop the recording there and just let some other people come in with their questions. But yeah, thanks so much for that.